I will try to focus on this one first, and then after that, after that we will discuss about some of the calculation. Dulu tak susah, and biasanya soalan dia sangat straightforward, so don't worry. Okay, to understand or to write an equation, you have to identify type of decay first. So for your syllabus, kita ada 4 types of decay. Okay. Number 1 is what we call alpha decay. Okay. Number 2 is beta plus decay. Number 3, beta minus decay. And lastly, gamma ray. Gamma apa? Gamma ray kot, saya ingat nama dia apa. Okay, so all these 4, dia sebenarnya ada reason kenapa dia bezakan benda ni lah. Okay, saya punya screen dia dah lagging sedikit. Okay, there you go. So, macam mana dia classify ni? Sebenarnya dia classify based on macam mana benda ni tembus benda lain. So, contohnya kan, kalau alpha decay, let's say if I put a piece of paper, so alpha decay, dia tak boleh pass through a paper pun. Even a piece of paper pun dia dah stuck. So dia mati kat sini lah. If you have beta decay, dia basically boleh pass through several object. Tapi kalau wall, dia sangkut. Wall dia mati lah. And then you have gamma ray, which is basically can pass through banyak benda, dan dia mati dekat sini. So let's say ni adalah apa ni? Nickel. Okay, in your opinions lah, which one yang paling bahaya?
Gamma.
Okay, so gamma dia bahaya tu in a way that kita susah nak halang dia pass through. Okay. Contoh ray gamma ni kalau katakan dalam kereta kamu kan, that's why kita letak tinted yang boleh block some of the gamma ray because it's quite dangerous lah. And then kita punya ozone sendiri ada lapisan tapis. Itu kalau daripada lights, daripada sunlight. Okay, but yang paling bahaya actually adalah alpha decay. Simply because alpha decay dia punya mass besar, so you will expect dia punya effect pun besar. So those yang terdedah kepada alpha decay biasanya memang ada high tendency untuk kena cancer ke, kena sakit ke, things like that. So this one is quite dangerous, so be careful. Let's say kalau one day kamu diberi peluang untuk kerja with radioactivity punya eksperimen ke, ataupun kamu masuk dalam X-ray ke, just be careful. Okay, so one of the two main person yang discover radioactivity ni adalah Becquerel and Curie. Jadi kita akan discuss lah pasal Becquerel and Curie. But saya cuma nak point out yang Curie ni dia adalah the first woman that won Nobel Prize, and dia meninggal tu sebab kena cancer due to radioactivity. So please be careful. Okay, back to the equation. So alpha decay, basically if you have an parents punya nucleus, atom, dia akan produce helium. Okay, so saya think that's lagging, I don't know why. So kalau dia produce helium, dia juga akan produce anak dia. So anak dia biasanya kita letak sebagai different symbol compared to bapa dia lah. So ayah dia tu kita letak sebagai X, anak dia tu sebagai Y. Saya still menunggu dia keluar kat skrin. Dia tak keluar kat skrin, dia sangkut dekat bar tu kan. Kamu nampak apa sekarang? Dia keluar pun. Sekarang nampak tak equation saya ada X dengan Y tu? Can you see that? Okay, nampak
sir.
Okay, so kalaulah yang asalnya tu consists of A and Z. Okay. So your Y tu mestilah A minus 4 and Z minus 2. This one makes sense lah. So if you do it like this, then it balance out. So example, katakanlah A tu adalah 13. Okay. If you put 4 over here, so this one will be 9. To example. Now this is just example. Okay, but if you write it like this, dia memang balance daripada A, tapi dia tak balance daripada segi energy. So you have to put another one, which is plus Q. Wajib letak. Dan letak je. Okay. So whenever they ask you to write an equation, make sure you put your Q over there. So this one for alpha decay. Yang penting, you write it this one, then ada Q. Make sure the balance lah. And then this one, since you already change the numbers of A, biasanya elemen dia bertukar juga. So kamu tak tahu dia tukar jadi apa. Contohnya katakan asal tu adalah aluminium. Basically you don't know what is this, you just put X ataupun Y. Anak dia tu kan, letak je X or Y. Jangan kamu letak sesuka hati and dia salah. Sometimes kalau kamu letak salah, maybe dia pangkah. Okay, any questions so far?
Ada, sir.
No, sir.
For beta decay, I don't know why I put ZZ in the arrow, so change this one. This part is straight arrow. Okay, for beta decay, kalau beta plus, obviously dia akan produce a beta plus punya particle. Okay, so if I want to balance this one, my daughter now would be, bukan my daughter, dia punya daughter ni would be A, Z now becomes Z minus 1. Okay, contohnya kalau yang Z asal tu adalah 10, this one will be 9 plus 1 lah. So simple thing, tak ada masalah. And then jangan lupa letak Q. And for this one is a bit special, you have to put V. Okay, V ni is actually what we call neutrino. Okay, neutrino ni exists because of the electrons itself. Sorry, positron. This one is positive one. This one is actually positron. Sebab tu kamu boleh letak E juga. E plus lah. You can put that one as well. And this one is positron. Partner dia adalah neutrino. Wajib ada. Dalam nota kamu tu, kalau kamu tengok kat slide tu, dia tak ada. So make sure kamu letak lah. This one. So if you put Q, it will balance out the energy. A and Z ni balance out dia punya atomic numbers lah. But the V here, they actually balance out the spin. So spin dia tu akan balance and dia akan jadi conservation of angular momentum. That one's out of the syllabus, but you need to put this one lah. You don't have to bother with the spin, but just put the definition. Faham ke tak? Can you guys follow this one?
Faham,
Okay.
sir.
Kalau beta minus pula, will be negative. So y dia now actually equals to z plus 1. A dia masih sama. So example over here, kalau ni 10, this one will be 11, and then this one is negative 1. So it balance out. And then to balance out the energy, you put Q. To balance out the spin, you put V bar. Okay, this one is actually your anti-neutrino or anti-neutrino, not sure. Again, this one exists because it want to balance out the angular momentum. And dia partner dia memang dengan electrons. So, cara saya hafal, kalau dia negatif dekat sini, dia ada bar dekat situ. Itu cara saya hafal lah. Kalau dia tak ada negatif, dia tak ada bar. Okay. And then, these two things actually is elementary particle. It's one of the smallest particle yang boleh exist, as small as electron in fact. So dia punya mass sangat kecil. So memang dia exist ni hanya untuk balance out the spin. Okay, and then the last one is gamma ray. So kalau gamma ray dia kasih senang lah. So X ni initially maybe dia excited. Kadang-kadang dia letak kat sini excited tu to indicate dia excited. Tapi saya biar dia kat sini. So excited punya form, dia akan decrease, dia akan jadi more stable. Okay. And just add a gamma. So kalau soalan ditanya yang ni memang bonus lah. Seperti yang kita dapat. Okay, ada soalan ke tidak?
Ada, sir.
Tak ada, okay. There's no question. Cuba kita tengok some of the example. Cuba kita buat, kamu buat. Example number 1. Let's say if you have, write down balance equation okay, number 1, uranium 23898 undergoes alpha decay. Okay, number 2, what if you have aluminium undergoes beta minus decay. So this one memang saya meletak je nombor dia. Kalau kamu check maybe nombor dia lain lah sepatutnya, tapi for the sake of learning, saya just pakai je nombor ni. Okay, cuba kamu buat sekejap. Saya kasih kamu masa dalam 2 minit. Boleh tak yang dah siap tunjuk saya? Cuba kamera and then show me what you should write. Masih menunggu tanpa jawapan. So mana? Boleh buat ke tak ni? Ada tak Arif?
Ada, sir.
Ada. Lain tak okey Arif? Kita rasa terkeluar je tu. Jangan. Okay, sini. Tak ada seorang pun tunjuk saya. Okay, tak apalah, kita buat bersama-sama lah. Okay, so asalnya this one is 23898. Okay, so dia akan produce apa? Kalau alpha decay, kamu pakai simbol apa?
Helium.
Helium. Nombor dia?
42. 42.
2. And then, dia ada tambah apa lagi tak?
Q.
Q. Okay, good. Ada lagi tak? Tak ada kan? Cuma sekarang ni kamu nak tulis anak dia lah. Okay, anak dia kamu boleh letak Y. You can put X. Tak payah letak U. Jangan letak U lah. So, kita tak tahu apa benda dia jadi sebenarnya. Okay, sekarang ni dia jadi apa? 2,
2, 3, 4 and 9, 6.
yes. Okay, good. Very good. 96 and 334. So, I always double check lah. 96 plus 2 is 98. 23 plus 4 is 238. So, markah ni biasa dalam 2. Pemeriksa dia akan tengok 2 benda je. This one, tally ke tak, and ada tak Q tu. Tu je. That's for example number 1. What if for example number 2? Katakan saya letak ni sebagai X. Salah. Okay, dia hasilkan apa kalau beta minus beta? minus. So nombor dia apa?
0, -1.
Okay, good. 0, -1. So dekat sini dia punya x tu
13 and 9.
okay, good. Very good. So 9 minus 1 is 8. 13 minus 0 is 13. So you are halfway there, tapi tak complete lagi. So belakang ni nak letak apa?
V bar and Q.
Okay, good. V yang ada bar sebab dia ada negatif kan, and then kamu tambah Q. Okay, perfect. So you should get full mark. So in exam, normally the question is like this, simple, straightforward. Tapi ada certain years dia maybe nak peningkan sikit, dia kasih benda lain lah. Contohnya katakan dia buat dan cerita that undergoes decay that produce two alpha particle. So letaklah 2 dekat sini. Itu contohnya. Ataupun let's say dia kata dia kasih yang ini dengan yang ini. Dia suruh kamu identify apa yang possible-nya dekat sini. Apa possible decay. So tak paling susah dia pun tak susah pun sebenarnya. So tak ada masalah. So ingat you have 4 types of decay. Make sure you manage to identify yang ni. Apa dekat itu. And then dia partner dia apa. And then should be okay. Okay, any question?
No, sir.
No? Kita proceed to calculation. Okay, so for calculation, you have decay law. Okay, decay law is actually dn over dt equals to negative lambda n. Okay, notice that I put negative over there, so negative memang kena ada. Okay, so that one is in your formula. So dn dt is basically your rate. So notice that I put rate, ada rate kat situ. Rate of nuclei decay. Okay. Sometimes we call this one as activity. So this one is equivalent to A. Kita boleh tulis sebagai A juga. And this A, unit dia actually adalah becquerel. This is the SI unit. So the unit would be becquerel or per second. Tapi kalau per second tu make sure kamu ada tulis rate. Contohnya rate is 500 nuclear per second. Itu dia make sense. Kalau kamu tulis per second je, dia macam tak kena sangat lah, tapi betul je sebenarnya. So dalam soalan, kalau dikasih ada rate, itu adalah A ataupun dn over dt. The unit is becquerel or S-1. Okay, sometimes, I can bring this one a little bit. Okay, sometimes, they might give you in C, Curie. Okay, Curie ni is not SI unit, so you have to convert to BQ first. How to convert? Dia ada dia punya formula, dia ada dia punya value, and the value is actually will be given in the exam. Dalam soalan tu sendiri dia akan beri. Kita ingat value dia. I have to check sebab saya punya buku tu dia lain. Okay, siapa boleh tengok? Satu becquerel, one curie is equal how many becquerel? Okay, so I got the numbers here. So 1 CI is equivalent to 3.7 times 10 to the power of 10 BQ ataupun per second. Okay. So far okay.
Okay, sir.
Okay. So kita baru cerita pasal A lah. We are talking about A and we are talking about dn over dt tu. The negative here indicates that dia adalah decreasing. So apa yang decreasing is actually numbers of nuclei is decreasing. So rate ni negative because number of nuclei, let's say daripada 1000, it will decrease to 9000, 5000, and 2000, and so on. Will decreasing. This one is the indicator. That's why you have to put negative inside the equation. Tolong letak. Okay, lambda there is actually your decay constant. Okay, lambda is equals to ln 2. So make sure you know how to press ln 2 inside your calculator over half-life. Okay, the unit, the SI unit would be S minus 1. So if they ask you to calculate lambda and they give you half-life, make sure you change your half-life to second, then only substitute inside this equation. Normally they will give you in year. Yeah? So your lambda, you can substitute inside here. The unit is second. So notice that the unit is actually quite similar to this one. Sebab tu biasanya kalau saya, I will write yang A ni with becquerel, tapi lambda ni saya leave it with S minus 1. Okay. And the last one is actually about N. Okay, N ni is really numbers of nuclei. Okay, please remember that numbers of nuclei is actually equal to numbers of atoms. So if you have 5 nuclei, basically you have 5 atoms lah. 1 atom, 1 nuclei. So itu kadang-kadang student dia tak perasan yang nuclei itu actually is just an atom. Okay. So far ada soalan tidak?
Ada, sir.
Okay. So this formula, the decay law punya formula, you can actually derive a little bit, okay, and then you can end up with another formula. One second, please. Okay, saya tulis di sini. So this formula dia boleh jadi dua formula. Okay, saya tukar fikiran. So these two formula, derivation ni kamu boleh check dekat nota kamu ni, dia tak ada dalam exam, so saya tak tunjuk lah, dia tak ada dalam kamu punya learning outcome, where lambda equals to lambda terbalik, n equals to n naught exponent negative lambda t, and then you have a equals to a naught negative lambda t. Okay, notice that saya ada letak not tu. Okay, yang not tu indicates the initial. Okay, so initial numbers of nuclei, initial numbers of activity, and lambda is actually your ln 2 over t half. Okay, so you have to calculate that one first. So I can write this equation. Normally, when you use this equation, it will become something like this: negative ln 2 over t half multiplied with t. Okay, so this two, the unit need to be the same. Kalau ni dalam year, ni dalam year lah, tak kisah. Tapi kalau kamu tak sure, tukarlah t half t kepada second, and then ni pun dalam second. So selamat lah. Kalau kamu yakin, as long as these two is the same unit, should be okay. Okay, now masa bila kamu nak pakai this equation, dan masa bila kamu nak pakai equation yang tadi tu, okay, you can use this equation bila dia tak kasih time. Dia memang tak ada kasih time. Over here, dia kasih half-life. Tapi half-life bukannya waktu ketika itu. So, soalan yang kamu kena pakai this one, they want you to find or they give you information about instantaneous time. So, dia akan cakap lah, after 5 years, n is how much? Find the lambda, macam tu. Okay. So, this one, equation these two, biasanya nak pakai dia kamu kena be careful a little bit. Okay. Sometimes they might ask you to take ln on both sides. Make sure you know how what will happen if you take ln on both sides. Kalau kamu tengok ni multiply kan dia jadi plus. Okay, things like that. Itu semua mathematics. Sepatutnya kamu dah belajar, sepatutnya tak ada masalah lah. But then nanti kita cuba tengok soalan and then we can understand. Kita boleh tahulah whether kamu understand or not. Okay, for now, cuba kita buat satu example. Let's try to do some example. Okay, fine. Cuba kita buat question 10. Okay, so far kamu boleh ikut tak ni? Are you guys with me?
Boleh, sir.
Boleh, sir.
Alright. Okay, this one is the question from your tutorial. Okay, suppose that probability that each nucleus will decay in 1 second is 1 times 10 to the power of S minus 1. Kita buat yang B dulu lah, A dulu sorry. And the numbers of nuclei in the sample is 5 times 10 to the power of 9. Calculate the rate of decay. Okay, so this number represent apa? Oh, lambda. Dia dah tulis dah lambda. This number represent apa?
Nah, N, sir. Number of
Yes,
atoms.
numbers of nuclei. Itu sama je lah. And is equals to 5 times 10 to the power of 9. Calculate the rate of decay. So soalan ni nak apa?
Rate of decay.
Yalah. Simbol dia apa?
Dn over
N over
dt.
dt.
dn over dt. For dn over dt, kamu nak pakai formula mana? Yang ada time, yang ada exponent ke tak ada? Tak ada lah. So ini je equation dia. You just have to substitute inside here. So lambda is given, n is given. So masukkan lah. So the normal question adalah should we leave the negative over there? Perlu ke saya hilangkan negatif dia ataupun saya biar je macam tu? Perlu tak saya tak negatif ataupun biar je?
Perlu.
Perlu biar je lah, biar je negatif cukup sikit sebab formula dia ada negatif because of it over there. What is the unit for dn over dt? Kamu boleh follow saya tak ni?
Boleh, sir.
Boleh, sir.
No, bahasa senyap
S negatif 1.
Okay, S negative 1 is correct, but normally I will write this one as becquerel. Sama je, dia adalah SI unit juga. Okay. Kita buat lagi satu soalan. So we try to do question number 10B. Over here in this question, the case it says that 0.25 kilogram radium 226 emits alpha particle at a measure rate of 9 times 10 to the power of 12. Calculate the decay constant of the radium. So the dict gives you decay constant. Sorry, they want to find lambda. Betul?
Betul, sir.
Okay. Yang 0.25 tu apa?
Mass, sir.
Yes, it's a mass.
S.
Okay, and then 9 times 10 to the power of 12.
dn over dt.
Dn over dt.
Correct. How do you know that it is the end of dt? You have to look at the sentence here. Rate gitu. Emit rate. So this one is actually your dn over dt. And in fact, you should put negative as well sebab dia adalah emits. So dia keluar, rate dia decreasing. Okay, dia decreasekan neutron, tetapi nak letak masa masuk dalam equation pun tak apa, saya tak siap. So basically you want to use dn over dt equals to negative lambda n. You already have the values of dn dt dah ada. You want to find n first. So how do you find n? Sama ada mass, nak cari numbers of nuclei or numbers of atom, pakai apa?
Find moles.
Yes, find moles first. So to find moles, you have mass, you have to divide by molar mass. Jadi kalau dalam fizik, molar mass is simply this number. Atom chemistry pun sama juga, you pakai tu. Tapi the actual one is slightly different. Kita pakai nombor tu. And then you have to multiply. If you do it like this, you get numbers of mole. You have to multiply Avogadro's number. Okay, so that you should get numbers of nuclei ataupun atom. So 0.25 divided by 226. But remember, this one, the unit is in gram. But your 0.25 is in kilogram. So I convert one of these. So I convert yang bottom tu kepada kilogram. So become 0.226. Multiply with Avogadro's number. Your numbers of nuclei should be
6.66 times 10 to the power of 20.
good. Okay. And then once you have this one, it's another lah. dn of dt equals to negative. Okay. Saya tak tulis lagi sekali lah. Saya tulis substitute nilai ya. Negative 9 times 10 to the power of 12 is equals to negative lambda. And it's 6.66 times 10 to the power of 20. So this one cancel out. So lambda is equals to 1.35, right? Salah kira. Betul tak ni? Tutorial.
Saya dapat lain, sir.
Dapat lain eh? Dapat apa? Saya
Dapat
tekan.
negatif 11 ke?
Sekejap aku tekan sekali. Mana yang saya salah? Ke dekat atas ni saya salah? Oh, ini positif.
Dapat. Dapat, sir.
Oh, I mean, tak
Dapat
saya salah
sama
tuliskan.
ke?
Kan atas ni saya salah tuliskan. Betul tak?
Power of 23.
Kan? Bawah tu 20 jugalah. Betul tak? So, yang kamu dapat tu sebenarnya betul. Sebelas eh? Betul?
Betul,
So
sir.
what is the unit?
Betul,
Okay.
sir.
Okay, good. What is the unit for this one? Okay, for some reason, saya dah. Okay, what is the unit for this one?
BQ.
Okay, BQ tu biasa kita pakai untuk A ataupun DNDT. Kalau lambda kita pakai per second. Memang benda yang lebih kurang sama. Cuma kita tak pakai untuk tu. Misal nak. You guys okay?
Okay, sir.
Okay, and then one more thing saya nak point out and equation dia adalah dn over dt equals to, okay, I can write dn dt tu sebagai a lambda negative lambda n. Kalau if I put this one as a naught, then not n will be n naught lah. Kalau saya kata A ni after t equals to 5 years, that means negative lambda n ni t equals to 5 years. So this is another important concept from the graphs. You need to understand that for this equation, A ni represent at that specific time. Masa tu berapa dia punya ni? Berapa A, berapa N. Kalau initial, N, initial A. Kalau T after 5 years, A after 5 years. So, apa saya tunjuk benda ni? So, sometimes they ask you to use this formula and they ask you to find N after certain years lah. And then final question dia kata, find the activity. So, you have to convert N ni kepada A tu. So, you have to use this formula. Okay, understand tak?
Faham, sir.
Okay, kalau faham, kita berhenti sini dulu. Kamu pun sudah detail ya. Next week kita jumpa and try to do all the questions and we discuss the question.